Hey there, science fans! Did you know that almost everything we do online is protected by clever codes? It's true. These codes keep our personal information safe. They protect our money during online transactions. But guess what? A new type of computer is coming. It's called a quantum computer, and it can break those codes. This isn't science fiction, folks. Quantum computers are super powerful. They use the strange rules of quantum mechanics to solve problems that would take regular computers billions of years. One of those problems? Cracking the codes that protect our online world. Think about it. All your emails, your photos, your online banking, everything could be vulnerable. That's why scientists are working hard on new types of codes. These codes are designed to be quantum-proof. We call this new field post-quantum cryptography. It's like a shield against a quantum sword. Let's dive deeper into the world of quantum computers and see why post-quantum cryptography is so important. To understand the challenge, we need to understand the difference between our everyday computers and these fancy quantum ones. Think of a classical computer like a light switch. It can be either on or off, representing 1 or 0. This is how it stores information in bits. Now, imagine a dimmer switch. It can be on, off, or anywhere in between. That's kind of how a quantum computer works. It uses qubits, which can be 1, 0, or both at the same time. This is called superposition, and it allows quantum computers to make many calculations simultaneously. Another quantum trick is called entanglement. Imagine two dimmer switches linked together. When you change one, the other changes instantly, even if they're miles apart. Entanglement lets qubits influence each other in ways regular bits can't. These quantum properties make them incredibly powerful for specific tasks, like breaking the codes we use today. Don't worry though. That's where post-quantum cryptography comes in. Remember how I said that quantum computers are great at breaking certain types of codes? Well, those codes are based on math problems that are easy for classical computers but hard for humans to solve. One example is factoring large numbers. It's easy to multiply two prime numbers together, but if I gave you a giant number and asked you to find its prime factors, it would take you a very, very long time. Classical computers struggle with this too, which is why it's a basis for many encryption methods. Quantum computers, however, can factor large numbers much faster. This means they could crack the codes that protect our online data. This is where post-quantum cryptography, PQC, swoops in to save the day. PQC uses different math problems that are hard for both classical and quantum computers. It's like building a fortress with walls too high and strong for any giant, even a quantum one, to climb. So, what are these super strong, quantum-resistant methods? Let's look at a few. Lattice-based cryptography. Imagine a maze with billions of paths. Finding the right one is nearly impossible, right? Lattice-based cryptography uses similar complex structures to hide information. Hash-based cryptography. Think of your fingerprint. It's unique to you. Hash-based cryptography uses similar digital fingerprints to ensure data integrity. Code-based cryptography. Ever try solving a difficult puzzle? Code-based cryptography uses error-correcting codes, turning data into a puzzle that's hard to solve without the right key. Multivariate quadratic equations. This one's a bit of a mouthful, but imagine a giant math problem with many variables. Solving it is incredibly complex, making it ideal for securing information. These are just a few examples of the exciting world of post-quantum cryptography. Researchers are constantly developing and improving these methods to stay ahead of the quantum threat. Remember, our digital lives depend on strong encryption. As quantum computers become more powerful, post-quantum cryptography will be crucial in keeping our data safe and secure. So stay curious, keep learning, and together, we'll ensure a secure future in the quantum age.